Let's learn about error handling in Python. Errors are quite common in programming. If you have been following along these videos, then you might have seen several different errors in my code. You don't want to show this kind of stack traces to users because it doesn't mean anything to them. They cannot even understand what those stack traces mean. Fortunately, Python provides convenient blocks using try and except statements to handle errors. There are multiple varieties of these except statements to handle different kinds of scenarios, and we will learn about them in this video. Python also provides a finally block which can be very useful when you want to clean up the resources in case some error occurs in the middle of the code. We can also make use of the raise keyword to throw our own custom errors using custom error messages. Let's take a look at a snippet of code for this try and except block. Inside the try block, we can write a code that can possibly throw an error. And when Python encounters this error, it will go to this except block and execute all the statements inside this except block. Let's learn more about this in code. While coding, you can always come across different kinds of errors. If you have been following along with this video series, then you might have seen that I have come across errors quite often. These errors are also called bugs in programming. When the Python interpreter is not able to understand the code we are writing, that's when it throws a syntax error. Let me show you an example of this. If I write if true, this is an if block, but if I don't write anything in the if block, then it will throw a syntax error. Python is unable to understand this if true statement because it doesn't have any statements inside this conditional block. Similarly, if I have a variable age with value of 21 and if I try to concatenate that variable with a string value, then it's going to throw a type error. It says can only concatenate string to string and not to integer variables. If I have a numbers list with 3 elements, and if I try to access element at index position 5, then it's going to throw an index error, list index out of range. These are some of the common examples of errors you can come across while you're coding. We don't want to show this kind of stack trace to our end users because it doesn't mean anything for them. They simply don't have any clue about this numbers variable, so showing this kind of errors stack traces will make them confused. In order to avoid showing them this kind of stack traces, Python provides try except block. This kind of try except block can come in handy when we want to avoid showing this kind of errors. Let me show you a very simple example of this. If I have a variable with a value of 0 and if I use this variable for dividing any number, then Python is going to throw a 0 division error. We cannot divide any number by 0. The value of this division operation is not defined. In order to avoid this, we should wrap this content in try block. So we can write try block here, and whatever statement that can throw an error should be wrapped inside this try block. So I can indent this statement inside this try block, and let's also print this one so that we can verify later on. After this, we can also write an except block, and inside the except block we can simply print something. We can write error occurred. Now if I run this cell, then it will simply print this error occurred statement. So when Python encounters any error in this try block, it can come from any statement in the try block. That's when the execution flows into this except block, and it will simply execute whatever statements we have inside this except block. Now this was a very simple demonstration of how we can use the try and except block. But this kind of generic error message will not help. We want to handle different kinds of errors differently, and that's where we can use multiple except statements for different kinds of errors. Let's take a look at an example of that. Now let's say I want to create a very simple calculator, but this calculator will only have one operation, that's the division of two numbers. So here I can take two numbers from the user using input function. And I have assigned those two numbers to num1 and num2 variables like this. In order to calculate the division of these two numbers, we have to first cast them to integer value type. So here I can write result equals int of num1 divided by int of num2. And this operation can throw an error. If the user enters number 2 as value 0, then it can throw a 0 division error. But if the user enters any alphabetic character as number, then it can also throw a value error when we are trying to cast it to integer data type. So we have to handle different kinds of errors here. So I can write try statement here, and I can indent this code inside this try block. In the except statement, I can write 0 division error. This block will be executed when our code encounters 0 division error. In this simple case, I'm only going to print an error message informing the user that the denominator cannot be 0. This will help the user to identify the problem and they can fix it. Similarly, it can also throw a value error when we are trying to cast a string data type into integer value. So here I'm creating another except block for value error. If you see the pattern, both these except block are written using except keyword followed by the error type we want to handle. Here I'm simply going to print please enter number and not string data. Let's also print this result so that we can verify. And I also have to cast this result variable into string data type in order to avoid the type error. So let's execute this cell. If I enter values as 1 and 0, then you can see that it returns this print statement, which is from this except block. If I execute this cell again, and if I enter the values as, let's say, A and B, these are alphabetic characters, so this time it's going to throw a value error, and you can see that it prints an error message from this value error except block. So this way we can handle multiple different error types in different except blocks, and we can perform different operations depending on the type of the error occurred. We can also handle multiple error types in the same except block. Writing multiple except block for each type of error may not be feasible, and that's why Python allows us to write multiple error types in the same except block. For example, let me copy this block and let me paste it over here. Now, if I want to execute the same code when value error occurs or 0 division error occurs, then I can write both these error types in the same except block like this. I can specify the errors that I want to handle in the form of a tuple, and when that kind of error occurs, it will simply execute this block. Let me remove this value error block. Now if I execute and if I enter values 1 and 0, then it will print this denominator cannot be 0. But if I execute this again and I'm trying to throw a value error by entering values as A and B, this time also it throws the same error message. So this way we can handle different kinds of errors in the same except block. If we write the same kind of code over here, let's say I want to handle both the errors in this block, but I also have an explicit value error block. If I run this code and if I try to throw a value error using input values as A and B, then you can see that it prints this message. When it encounters value error, it will simply go to first except block where we are catching that value error. In this case, it's this block, and that's why it executes all the statements in this block. It doesn't go to the next value error block. It will simply exit once this except block has ended. This means we have to be careful in sequencing our except block in the correct order. If we want to handle value error explicitly, then we can write this value error block before this block, and that will make sure that we are printing this error message for value errors. Let me remove this value error from here. We can also create an alias for this specific error object. For example, if I want to get the error message from the Python interpreter itself, then I can write as some variable name. In this case, I'm naming it as ZE. And for value error, I'm going to write as VE. This is the error object itself, and we can get an error message from it by simply printing that error object. So if I print 0 division error and if I print this value error, then it will print that specific error message from the Python language itself. Let me run this again. I'm entering the value 2 and 0, and you can see 0 division error. It prints these two error messages. This one is the custom error message we have entered, and this is the error message from the Python language itself. So this way we can make use of this error object. Now Python also provides a raise keyword which can be used to throw our own custom error messages. For example, if I want to throw a value error, I can write raise value error, and I can write my own custom error message here. If I execute this, it's going to throw a value error with error message I have provided here. We can make use of this raise keyword when we want to execute code based on specific condition. If that condition is not satisfied, then we can throw an error. Let's say we have a use case where we want to add two numbers only if those two numbers are greater than 0. If the number is negative, then we don't want to handle that case and we can simply throw an error. So for that, we can write code like this. I'm accepting two numbers, num1 and num2. Now I'm typecasting both the numbers into integer variable value. Finally, I can verify if any of these numbers is less than 0. then I can simply raise value error. If none of those values are negative, then I can print the sum of those two numbers like this. Let me execute this. If I enter values as 1 and 2, it prints the sum correctly. But if I execute this again and if I enter 1 and -1, then it's going to throw a value error. And here you can also see the error message we have provided over here. We can also wrap this code inside a try and except block to handle this value error. Here, for example, I can write the try block and I can indent all the code inside this try block. At the end, I can write the except block. If I execute and provide values as 1 and -1, it only prints the error message from the except block. Python also provides a convenient finally block which can be useful when we want to clean up the resources that we have opened in earlier try block. This can come in handy when we are working with files. While working with files, we first have to open a file, then we can work with that file, and finally we have to make sure that we close the file. If we forget to close the file, or accidentally if some error occurs in between our code, then the file closing operation is never performed. This results in unnecessary resource consumption in our system. This is where we can use the try, except and finally block. Let me show you a simple code for that. In this simple case, I have a file in my data directory in my project folder, sample.txt, and if I open that file, it has the content of 3 lines, 1, 2, and an alphabet character A. I want to write a code that will sum all the numbers from this file. So let's try that using try, except and finally block. First of all, I have to open that file using open function. I am also initializing a sum variable with initial value of 0. Inside the try block, I can write calculating sum. And here I can iterate through all the lines of that file. For that, I can make use of readLines method. Each line is going to return a number, but we also have one alphabetic character in that. So this typecasting operation is going to fail when it encounters that alphabetic character. Here I'm adding the number to the sum variable. In the except block, for simplicity, I'm going to write an error has occurred. If I execute this cell, you can see that an error has occurred. But if I verify if my file has been closed, then it returns false. That means my file has not been closed yet. Let me close the file using close method call, and now my file has been closed. If I add finally block in here, finally, and inside that block I can close the file, f.close. Now the benefit of this finally block is that it will always be executed regardless of whether there is an error or not. If I execute this, then you can see first the execution flow went into this try block. When an error occurred, the execution also went into this except block, and finally the execution flows into this finally block. So that means it has already closed my file. I can also verify that by using this f.closed attribute, and it returns true. If I correct my file, let me remove this character A and insert a number 3. Let me save this file and close it. Now if I execute, it is going to correctly sum all the numbers from that file. Even though it didn't throw any error, the finally block was still executed. So this way we can make use of this try, except and finally block to handle file operations when we are not using the with block. In this video, we looked at how we can handle errors in Python. We also saw how we can handle multiple types of error in different except blocks. We saw the use of raise keyword to raise our own custom error messages. And finally, we looked at this try, except and finally block to make sure that we finally close the resources that we have opened in our code.